Good afternoon, everyone. Welcome to the Southwest Drought Status webinar. This series of webinars was initiated due to the severity of the drought in the Southwest region. This webinar will provide the most recent information on the drought, impacts of the drought, and the upcoming monsoon season in the region. My name is Elizabeth Waite, and I am the NOAA's National Integrated Drought Information System Regional Drought Information Coordinator for the Intermountain West and Southern Plains Drought Early Warning System. NIDIS, or the National Integrated Drought Information System, was established under NOAA to support research on how and why droughts affect society, the economy, and the environment, and to strengthen drought early warning systems. A critical aspect of drought early warning systems is coordinating agencies that are key players in drought monitoring, forecasting, planning, and communication. Those agencies have been very involved in this webinar. It's a truly collaborative effort to bring you this information. The agencies include NOAA's National Weather Service, USDA, Western Water Assessment, Western Regional Climate Center, Climate Assessment for the Southwest, state climatologists, National Drought Mitigation Center, and many others. Today's presenters include Becky Bollinger, Colorado's Assistant State Climatologist. She will provide an overview of the drought and the drought impacts. And also Brian Klimowski, the National Weather Service meteorologist in charge of the Weather Service office in Flagstaff, Arizona, and Emily Elias, the USDA Southwest Climate Hub Director. Emily will direct the Q&A portion of the webinar. During the webinar, participants are muted, so if you have questions, please type your questions into the question box. The Q&A at the end of the webinar will direct your questions to the appropriate expert. Finally, today's webinar is being recorded, and the recording and a 2-page status report will be available on drought.gov. And the next webinar will be held on the 25th of July from 10 a.m. to 11 a.m. Mountain Daylight Time. And the speakers will be Nancy Sullivan, the state climatologist for Arizona, and Ed Delgado, the National Interagency Fire Center Predictive Services Manager. And now I'm going to turn it over to Becky Bollinger, who's going to give us a presentation on the drought status and outlook.
So I got a lot of information. I will get through it as quickly as I can. Starting by showing everyone what the current drought looks like over our region and the evolution of that drought. This is last week's latest update from the U.S. Drought Monitor for the Southwest region. You can see where we have widespread drought in those Four Corners states areas. These red colors are really what I want to highlight. The red is a D3 extreme drought category, and the maroon is a D4 exceptional drought category. These are drought categories that are very rare, like less than a 5th percentile frequency of occurrence. So when you see that D4 category, we're talking maybe a 1 in 50 to 1 in 100 year event drought that covers the Four Corners region and extends down into central Arizona and across northern New Mexico. And currently that D4 category is taking up 7% of this entire Southwest region, and most of the region is in some sort of drought from D1, moderate drought, all the way to that D4. This is how the drought has changed since the last month. I believe there was a drought webinar for the Southwest on May 23rd. So since the May 22nd release to the June 19th release of the U.S. Drought Monitor, we haven't seen much changes. That's the gray no change across the region. Just very minor degradations, so worsening drought categories in that yellow there in New Mexico and northern Colorado. Some minor improvements made on the east side of the region, but largely no change over the last month. And this is how the drought has evolved since last year at this time, where we had mostly some abnormally dry conditions over the southwest region, a little bit of moderate drought in that D1 category, and then the lack of a good strong monsoon season in the late summer and into fall kick-started this expansion of drought categories in the southwest here, with D1 increasing. By the time we got to January, we were starting to see the effects of a snow drought throughout the higher elevations of the southwest, and that's when we expanded our D2 severe drought and introduced the D3 extreme drought. And it has been increasing ever since then, but it is kind of flatlined, as you can see here in the last month. We're going to take a look at the recent climate, including the precipitation and temperature and a couple of other variables that may be of interest. One thing I want to point out, this picture is from the Denver Post, which was an article talking about record high temperatures in June. And we've seen hot temperatures throughout our drought region in the Four Corners states and in Colorado. One of the impacts we've seen is a much higher number of 90-degree days in early June than we normally see. So that's been a factor. If we look at the entire water year to date, so that's starting from October 1st and then go through the end of May, what have things been looking like across the region? So in the upper left corner, we have the temperature rankings across this region for October through May. And when you see these yellows to reds, we're talking above normal temperatures. And when we get into the red, we're actually looking at the record warmest time period when comparing to all those other time periods back over 100 years throughout Arizona and through many portions of New Mexico, extending into southern Colorado, record warmest. And if we look at that same period for precipitation in the lower right, we're seeing much below normal precipitation, bottom 10th percentile ranking. So 10th percentile would mean 90 years would be wetter out of every 100 years. And then we also see that red showing the record driest also popping up. So both maps are quite concerning and lead to very damaging drought situation. So this is what May all by itself looked like. We did have a lot of those warm temperatures throughout the region with some record warmth in the higher elevations of Colorado and extending into northern New Mexico. Precipitation, we had a lot of dry areas in western Colorado and a large-scale record dry May for southern Arizona and southwest New Mexico, with a little bit of a wetter signal as you go into the northern part of the region. Quick look at what we've been seeing in June. I feel like I'm sounding like a broken record, but we've seen a lot of the warmer than average temperatures continue for most of this region. And the reason that warmer than average temperatures are going to be so important is in the winter time, it means you're not going to be accumulating that snowpack that you really need to build up the water supply. When we get to the summer, warmer than average temperatures are just going to increase the amount of evaporative losses you're going to see. So when there is water, it's going to be that much quicker to evaporate, which just worsens any dry conditions that you have. The precipitation departure from average for June so far doesn't look too bad. It's mostly hovering in that near normal range. So these yellow colors are near normal to about a 1-inch deficit, and then the green is near normal to about a 1-inch surplus. So we really haven't, this is why we haven't seen a lot of changes with the drought monitor over the last month. We haven't seen enough precipitation to approve conditions widespread, and it stayed dry, but not so dry to have widespread deterioration in drought conditions. So this is a look at vegetation conditions across the region, and this is from a product called VegDry, which takes basically a satellite derivation from satellite products and combines it with precipitation to see what those ground level conditions are looking like. And it follows along pretty closely with where we're seeing precipitation deficits and soil moisture deficits, which is a bullseye of very dry vegetation right around the Four Corners region, all throughout Arizona, and extending through most of eastern Utah as well. I wanted to quickly talk about stream flows in the upper Colorado River Basin and the lower Colorado River Basin. That's what you see left and right. And what this does is it takes an area average of all the individual stream gauges that are reported by the USGS. And this is over a 28-day average period, so it's a little long-term stream flow analysis. And what we're seeing is if you're in an orange or red color, the stream flows are low. And we should be getting back to a base flow, which is after your snow is melting and your rivers are high. They start coming down this time of year and eventually return to their base flow, which is usually sometime in September that we see that. But what we're seeing here is much lower flows than we normally want to see this time of year. We're looking at that bottom 10th percentile for the majority of the upper Colorado River Basin, all the way down to Lake Powell. And then as you go past Lake Powell into the lower Colorado River Basin, into that below normal category in a couple of spots, and right here around Lake Mead, showing that record low category. So very concerning when looking at rivers throughout the area. And what this means is we're not replenishing the water supply in the Southwest. This is looking at Lake Powell, which you could consider to be the bank account of water for the upper basin states of Colorado, Utah, Wyoming, and it's what the southern lower basin states would take when they need water. And we want to be in this normal range, which is the green window right here. And we were a little bit last summer, so we have finally started replenishing that supply after a very long-term drought. Unfortunately, right here in the spring, in this May, June, July period, you want to see a swift bump up in what goes into Lake Powell, and this year we haven't seen that. And it won't be surprising if we get into this lower 10th percentile range of water in Lake Powell, which is very concerning and will have more long-term effects than just a short-term or single-year drought. I wanted to focus a bit on the wildfire season because we've been having a lot of fires. This example, I got this picture from Emily, which is from the 416 fire near Durango in southwest Colorado. Here's a recent map I pulled from InsaWeb showing all of the active fires that are throughout our region, and a couple that I wanted to highlight. Thankfully, in Utah, Arizona, a lot of these that have been reported in InsaWeb are showing a higher percent containment, but we're looking at a almost 20,000 acre fire in Utah. This one in western New Mexico is at 50,000 acres, 85% contained. No longer active on InsaWeb, but the Ute Park fire in northern New Mexico was quite large. Again, there's the 416 fire in Durango, which just over a week ago was at 18% containment and increased to 37% containment thanks to the moisture we saw from Tropical Storm Bud, which you'll hear a little bit more about later. But we haven't really increased the percent containment since then. So some rains have been able to slow the spread a little bit, but these rains aren't stopping these fires from occurring. And then the last one in the far northern fringes I wanted to point out is the Badger Creek fire, which is actually in southern edge of Wyoming, which kind of points to areas that are not in drought, still see fires. This is the wildfire season, but what I'm hearing across the board is that it is a more active fire season than what we normally see, and that is largely attributable to drought. So a few random statistics I wanted to share. The first was that there are 28 active fires listed on InstaWeb in the last 2 weeks. That's over 170,000 acres that I could find of new fires since mid-May in that 4-state region. The majority have been human-caused, with a few that were lightning-caused. For example, Nancy Sullivan in Arizona told me that by the end of April, 604 of the 611 wildfires that had occurred in Arizona were human-caused. Only 7 were from lightning. So one of the major impacts we can see after a fire has occurred is increased risk for flood, and this is something we're all going to have to be aware of as we get closer to the monsoon season. This is an infographic from FEMA.gov talking about why we are at such an increased risk of flood after fires, and it's because we're changing, the fires are changing the vegetation and almost creating a repellent layer, so the water can't infiltrate the soils at all, and all of it runs off. So that is something to be aware of and to share information with people you know once fires have been put out, that this will be a concern. Other impacts have been national forest closures, a lot of them in Arizona, Apache, Navajo, and several in going into New Mexico and in southwest Colorado, the San Juan National Forest. These are all forests that see large-scale closures, partially from wildfires occurring, also partially from wildfire risk. They're just trying to get a little bit better containment on the situation, but this has far-reaching consequences, not just from a fire perspective, but from a recreation perspective. This is people not being able to visit these national forests, which is going to have an economic impact. If you look on the right side, I have a list. Basically, every state in that 4-corner state region has fire restrictions occurring. I'm sure this will not only have an impact on, again, the recreation, but as we approach the 4th of July, there's probably going to be some disappointed people not being able to see some fireworks. A few other impacts I wanted to talk to, particularly on the agriculture side of things. This was a photo I got, and this is actually from southeast Colorado, so more of a southern plains drought type thing, but I liked the picture because you can see the barren landscape with a cow there reaching under a fence to try to get to graze on something a little bit better than what it had access to. So this is our really large impact in the area, is a ranching impact. We don't have precipitation. We haven't had precipitation in a long time on these dryland fields and native grasslands, which means there's no food for cattle. Drought means there's no water for cattle, especially when ponds are drying up. So this results in ranchers having to haul in hay and water. We've also heard many impacts of liquidating or culling of herds, and this is reported throughout all of the 4-corner states. This picture I got from a news site in Utah, where the one irrigation company's records show that San Pete County in central Utah hasn't been this dry in 41 years, so suffering major impacts there. This picture is from northeast New Mexico by Royce Fontenot from the National Weather Service, and he included a description which I loved and I wanted to share with everybody, where he said basically the ecosystem has been starved for a long time with just an occasional dollar menu cheeseburger thrown to it. And I like this because it means that small rain events aren't making a dent in this drought. It's just been dry for too long. So the next questions are in an outlook. How would we get back to normal? And I'm sure many of you have heard of El Nino, so what's in store for us if El Nino arrives? I quick wanted to show the seasonal outlook from the Climate Prediction Center. The left shows what the temperature outlook is for the July, August, September time period. And those red colors are showing an increased possibility for above average temperatures, which we see widespread across most of the country. And the one on the right is a precipitation outlook for the July, August, September time period. And this green here, that bullseye right over the four corners and into Utah, is saying that there is a slightly increased chance of above average precipitation. And so the Climate Prediction Center is seeing something there that's saying they think that the monsoon may be better than average. Fingers crossed. You'll hear more about the monsoon in just a couple of minutes from Brian. So one of the things I want to talk about is what does it take to get back to average? And I think we all know June is a pretty dry month, so it's going to be really hard to get back to average in June. And this map kind of highlights that. What we're looking at is the proportion of annual precipitation you get in any given month. So where you see the brown colors, it means that in a typical June, you don't get that much precipitation that contributes to your annual total. And where you see green, you get a much higher proportion in June than throughout the rest of the year. So we see throughout, starting in the Four Corners and then extending southwest and throughout Arizona, basically June does not contribute much to the annual precipitation total. And short story to this is that you really can't get rid of a drought in June. If the drought's there, you're going to have to hold on to it for a little longer. Now, when we forward to July, the same map, we start to see a different story, and this is that hint of what's to come when you typically have the monsoon start, because you can see it bubbling up in the south here in southern Arizona and New Mexico, that they get a good chunk of their precipitation in June. And then when we go into July, you see that spread throughout Arizona and New Mexico and into southern Utah and southern Colorado. A large proportion of the annual precipitation will fall in August, in a typical August. So these are the months that provide a better opportunity to start chipping away at drought if we have a normal year. That's the key point. I didn't have time to make a lot of these precipitation projections, but I wanted to show you one for southwest Colorado in Cortez. This is fairly close to the Four Corners region. What we see here is how precipitation has accumulated since October 1st in this black line through June 25th, currently at 39% of average. That's at 3.16 inches, which is a 5-inch deficit since the beginning of the water year. So what can happen from here? Here's our average for a typical year. So I plopped the average in green right at that starting point of June 25th. And if we had average precipitation till the end of September through the rest of the water year, we'd end at 60% of average, so pretty darn dry. If we had a very wet year, a very wet summer for the rest of the summer, and for southwest Colorado, water year 2013 was almost record wet. And if I plop that on here, we still could not get back to average. We would be at 85% of average, which would be a vast improvement, but not back to average. So it's going to take a lot to get back to average. If we continued with a very dry pattern like we did in 2000, we would end the water year at 39% of average. So if we get in that above average, what the Climate Prediction Center is showing, We can hope that maybe we'll be a little bit above this green line, probably not to the blue line, but hopefully somewhere in between. But we are not going to get to average by the end of this water year is pretty much what this shows. So you might have heard recently that the Climate Prediction Center issued an El Nino watch. And what this means is that they're seeing that we're likely to go into El Nino conditions this fall. And here are your little 3-month periods, May, June, July, August. And the red is showing the likelihood of having an El Nino. So low likelihood now, we're in neutral conditions. But as we progress into the fall and towards the winter, there's a greater than 50% chance that we will be in an El Nino. And that is possible to be at a moderate strength El Nino during the fall and winter. What does this mean? Well, first I want to point out the winter La Nina pattern from climate.gov on the left side. And here you can see part of what contributed to the drought that we're in now, the position of the jet stream, keeping the colder, wetter weather to the north, and to the south, drier and warmer, which is what we basically saw. So the winter El Nino pattern does a little bit of a flip as the jet stream is pushed further south. We are more likely to get the wetter, cooler conditions in the south, a little bit variable as you get into the Four Corners, into Utah and Colorado. It really depends on where that jet stream lines up. One other thing I wanted to show, this is from a NOAA's Earth Systems Research Laboratory, talks about the increased risk of wet or dry extremes during an El Nino. So this is looking at the September, October, November time period. On the left, we can see that the greens show that there would be an increase in wet extremes throughout the Four Corners states. And then over here, the green shows that there would be a decreased risk of dry extremes during an El Nino. So basically what this means is you're more likely to get wetter than average time periods and less likely to get drier than average time periods, which is good news if it pans out. And then this is looking at the December, January, February time period during an El Nino. And we see that continue, especially for Arizona and New Mexico, that increased chance for wet extremes, decreased chance for dry extremes. This is going to be good for getting out of drought. Areas that have burn scars from wildfires, that will probably mean they have an increased risk of flooding throughout this. But we'll hold on to this and hope that that pans out. Final slide, I just wanted to share my email address. Email me with any questions that you might not have time to ask on the call. And I am done with mine.
Excellent. Thank you very much, Becky. That was a great background, great information on the drought and wildfire and the impacts of the drought, as well as the outlook. Thank you. Now I'm going to turn over now to Brian Klimowski with the National Weather Service.
All right, Becky, thank you. That was an awesome presentation. Can folks see my screen right now?
Perfect. Thanks, Brian.
Yes.
All right, let's go ahead and get started here. This is really one of my favorite topics and favorite times of year here in the Southwest. Coming out of the brutal and relentless Junes we tend to have, which are dry and hot, into what can be a very beautiful time of year. We're just going to spend a little bit of time here talking about what the monsoon is, what kind of signals we're looking at right now for the onset of our monsoon here in 2018. Anyway, the North American monsoon, it's a pretty dramatic seasonal weather pattern that I should say seasonal weather pattern change that we see here in the Southwest that brings a significant percentage of our annual rainfall to the Southwest. Becky showed some of that in her slides. This kind of echoes that, where the shading you see in the image on the bottom, the darker blue, the greater percentage of rainfall or precipitation occurs during the monsoon, during the months of July, August, and September. Here in my neck of the woods, here in Arizona, that's normally 20 to 40% of our precipitation falls in these 3 months. New Mexico, it's higher, about 30 to 50%, little less up north. Down in Mexico, and in the Sierra Madres and further south, you'll see those percentages, 60 to 80% of their annual precipitation comes in just these 3 months in response to what we call the North American monsoon. So what is the monsoon? Really, it's a seasonal change in wind direction, or a seasonal change in our weather pattern that we see most dramatically between the months of June and July when it starts. What you see here on the screen is a average airflow or weather pattern in the middle of the atmosphere, let's just say, which shows high pressure over central Mexico and southwest flow over the southwest. Now, this airflow is dry. It comes from the cool Pacific, doesn't bring much moisture, and unless there's a strong trough involved, this is responsible for the dry, incessantly blue skies we see down here in late May through much of June. But the incessant warming of the southwest and the Four Corners area causes a change that we see typically in late June and early July. What it tends to do is bring that high pressure farther to the north. Around the Four Corners area, we call it the subtropical high, migrating further north in response to the warming of the Four Corners area of the desert southwest. It also generates low pressure at the surface. I like to track things in the mid-levels like this. And what that change in the position of the subtropical high does is it starts to bring in moisture from a different direction. Okay, we start to see a feed from the south and east. This allows us to tap the rich moisture sources from the Gulf of Mexico, from northern Mexico, from the Gulf of California, and bring it up into this region of Arizona, New Mexico, Utah, and Colorado, and start that cyclical pattern that most of us love, called our summer thunderstorm season, or the monsoon. Kicks in late June in northern Mexico and maybe far southern parts of Arizona. New Mexico frequently sees it by that point. Works its way into my neck of the woods here in northern Arizona by the first week in July, and typically not too long after that for Utah and Colorado. I'm going to spend a bit of time right now talking about what kind of signals we're seeing right now for the onset of the monsoon. If you're going to ask me a couple weeks ago when I thought the monsoon was going to begin, I would have given you a different answer to what I'm going to give you today. It really looked like things were on track for probably an early onset here a couple weeks ago, but that was and is not the case. What we're currently seeing across the area is the monsoon pattern really is trying to set in, but we've had a series of western troughs that are bringing in drier and cooler air, which is really disrupting the monsoonal pattern and sweeping out the moisture. We've had a couple of these come through over the past couple of weeks. We have one more due later on this week, which is probably going to bring some critical fire weather conditions, pretty breezy and warm conditions later on this week. We're also seeing that the thunderstorms over northern Mexico are somewhat suppressed at this time, but the Sierra Madres, we saw a lot of activity a little bit earlier, but not so much right now. We like to see northern Mexico very active. That generates normally a pool of moisture, which tends to seep toward the north and seed the monsoon in southern Arizona and New Mexico and start the onset there. However, there is really a pretty good surface moisture not too far to the south. All we need to see is that pattern change in the mid to upper levels to draw that moisture farther north. And what I like to tell my partners and folks here is be patient, my friend, it will come. People ask me, so Brian, is the monsoon gonna come this year? It's so dry, and I always say yes. Then they say, okay, Brian, when is the monsoon going to start? And I say, Yes. You know, the monsoon just doesn't start on a dime. It's a pattern which has to take hold. What we're looking at right now, the numerical models that we have do go out far enough to capture the onset of the monsoon. And what it looks like is after another breezy frontal passage that I mentioned earlier, Friday and Saturday, that the more consistent monsoon circulation is likely going to set in between July 6th and 9th. We're seeing this in many of the models, in a lot of the ensemble solutions that we're looking at. It'll probably kick in a little bit earlier in New Mexico, start to see some scattered showers and thunderstorms, maybe July 4th and 5th, but with a pretty broad pattern change, probably in the 6th through the 9th, taking hold. CPC Outlooks, as was shown by Becky earlier, show that for July and the duration of the monsoon season, July through September, these are tilting in favor of a wetter than normal monsoon, and we'll chat a bit about those a little bit later here. The image I'm showing on the bottom is really, it's an ensemble mean, or it's an average of a bunch of model solutions for July 7th, showing that big H, or the center of that high pressure, that subtropical high that we want to migrate further north, indeed being right over the Four Corners area by July 7th or so. So there's starting to be some what we call model consensus for this change, for this monsoonal change and monsoonal pattern starting to take hold early in the second week of July. Let's take a look at some of the CPC outlooks for the medium to long range. Here looking at the July 2nd through 8th precipitation, showing a tilting in favor of above normal precipitation. That's that green area, and that A you're looking at there straddling between Arizona and New Mexico. This is really hitting on the latter part of this period, probably the 6th, 7th, and 8th. Looking toward the 3 to 4 week outlook, July 7th through July 20th, shows very similar pattern increasing over the area. Text and discussions from CPC are indicating what they anticipate could be a rather robust start to the southwest monsoon in July. I certainly hope that occurs. We certainly need the precipitation. As Becky showed earlier, looking at the longer term outlook for the monsoon, July through September, this is the same image she had, just presented a little bit differently, showing a tilting in favor of a wetter than normal monsoon for July, August, and September. When looking at the reasoning behind this from CPC, some of this is a result of a greater chance of some tropical activity making it up into this area, especially later on in the monsoon, somewhat like we saw from Bud here about 10 days ago in the area. That's my presentation. Keep it nice and short and save time for any questions if need be.
Excellent, thank you. This is Emily Elias, and if you have any questions for the presenters, if you could please tap them into the chat box. I'll go ahead and read those. The first question is from Dan Elliott, and it's a question from Brian. The question is the July 6th through 9th start of the monsoon later than usual, Brian?
Yeah, you could say it's just a tad later than usual. So yes, normally we'd see more activity in northern Mexico right now, and it kicking in southern Arizona and New Mexico a bit earlier than that.
Okay, great. We'll leave a little time for other questions, for people to type any questions they have into the chat box. Right now on your screen, you'll see some resources that we pulled together as a team that might be helpful for people in the region who are suffering through this long drought. The drought.gov website is one you might want to note. That is where we'll be posting this webinar recording and our 2-page summary of the webinar. We will also be having another webinar to see if Brian's predictions were correct about when this monsoon will happen, and that will be in a month from today, July 25th. And Nancy Sellover, the state climatologist for Arizona, will be leading that along with some fire information. Any other questions? Right, so here's another question from Dan Elliott, and he's wondering, Brian, will you please restate the prospects for this year's monsoon in general? So I might be able to go back to the slide potentially, but he's wondering if it's normal, more precipitation than normal, or less precipitation than normal. So really interpreting some of those maps that you showed from the CPC.
Yeah, great question. The Climate Prediction Center is tilting the odds toward wetter than normal for this monsoon season, as defined by the months of July, August, and September. There aren't really that many forcing mechanisms out there. That is, right now, we're in kind of an ENSO neutral state right now. They did mention in their discussion perhaps an enhanced chance of more tropical activity late in the monsoon that might bring in some moisture late this summer, early this fall. And that's one of the reasons for the wetter than normal prediction.
Okay, great. Thank you. I had a question actually for Becky, and this is about something that you mentioned related to the fires. One is that every state has fire restrictions, and I wonder if you have any information or knowledge about ideas about those changing into the future and what's happened with those. And then my second question was, do you have any recommendations for for those communities that have had these large fires, and what to watch in terms of the flooding risk that you mentioned? And everyone can respond to that, but I was hoping Becky would first.
Hi, so I'm not being a fire expert, I don't know really what to say about what's to come. I'd say that we're still in wildfire season, and one of the risks we could see with the start of the monsoon as well is increased lightning activity, which will further contribute to that. So initially, recommendations I would give would be to look for your state. I simply Googled state and fire restrictions and found a lot of information for each of the states. So where you are, I would highly recommend to do that, to look up what the fire restrictions are. Fire restrictions can range from anything to being pretty minor, and you just can't have an open fire at a campsite, to being a little bit more strict. For example, when I saw in Colorado was you couldn't smoke a cigarette in the public lands there. So it's very important to know what those fire restrictions are, and I would say especially if you're deciding on what to do with your 4th of July festivities, there could be restrictions on using grills for grilling out. There could be restrictions on not having personal fireworks, and heeding those are going to be very important, even if it feels like it's not a pun here, opposite of a pun, but raining on your parade. But I think the statistic that Nancy shared with me, that 604 of 611 fires through the end of April this year in Arizona were human caused. We can do a lot for fire prevention. So be aware of the restrictions, follow the restrictions. That would be my best advice for everybody. And in terms of the flooding, I would just say as we enter the monsoon season, not only will there be increased risk for more fires starting because of lightning, but that will be when we'll have an increased risk for flooding too. And generally, we could see that for several years after a fire has been put out and there is a burn scar. The vegetation is gone and the land cover is just different, and it doesn't absorb that precipitation like it does normally, and so you're going to have those flash flood risks. So if you're traveling in those areas, especially in canyons, pay attention to the weather forecasts, and if there's precipitation, just be very cautious over that.
Excellent. Thanks, Becky. One request that just came in from Helena Deswood was to, if you could please bring back the resources slide. So Elizabeth, if you could return to that, that would be great. And one thing that is on the resources slide is the post-fire flooding website. So that is a place for communities to go to learn about help. So that's one thing that we could point out. There's another question that came in, and this again will be for Brian, and it again relates to those Climate Prediction Center maps. And so the question is, if the probability for increased precipitation is 33%, which is one of the categories that you'll see, can a figure be given for how much the increase will be as a percentage of normal? So for example, if normally you would have 3 inches of precipitation in that 3-month period, would that potentially translate into 4 inches of precipitation? Can you make that translation from these predictive maps?
And I would say not easily, and perhaps not appropriately. We're looking here at likelihoods of, or I should say not likelihoods, but chances of whether we're going to be above normal, below normal, or near normal. And I think it's, you know, you're looking at slices of a pie that, you know, normally vary by 5 to 20% or so. To correlate that into amounts, especially during the convective season, no, or at least I don't think of it that way. And, you know, I'll just say no.
Hey, Elizabeth.
Yeah.
Yeah, this is Victor. I'll try and answer that. For any given location, you've probably let's say you have, you know, 90 years of weather data. You can break those 90 years up into your bottom tercile, your driest third, your middle third, or near normal third, and your wettest third. So if you look at the location in question, maybe look at your middle tercile. So the bottom end of that middle tercile would be, you know, the drier end of normal. The upper end of that tercile would be the, you know, the wetter end of normal. And so I think you could probably safely say that an above normal forecast would have, you know, X amount of probability of being in that upper tercile. And you can find those terciles. Whoever asked the question, I'll be glad to, you can send me an email offline or something, glad to answer that. If you want to forward to me, Elizabeth.
Great, thank you, Victor. That was Victor Murphy. And Mac says thanks as well for responding, both Brian and Victor, to that question. And we're looking, are there any other questions? We'll give it a minute for people to type any last questions they may have.
This is Nancy. I don't have a question, but on Becky's map, she had one of the maps showed the departure from normal or percent of normal for precipitation for the month of June. And it showed much of Arizona having green tones. Well, that's true. Typically in June, we have virtually zero precipitation anywhere in the state. So if any place got anything, it would be showing above normal. And we're only talking about maybe 107 inch to maybe 407 inch. So not to be confused with actually being wet. It was not a wet June for most of the state. There was a couple places got a little bit more than that when Bud came through, but otherwise it was very dry.
Oh, excellent. Thank you, Nancy, for that clarification about the difference, between total amounts and what normal might be. One more question.
This is Becky. I did just want to add to that that's very important, and that is one of the things that really is missing from the Climate Prediction Center maps, is that above normal can mean very different in a dry season versus a wet season. And I would say that from June to July, you're going to be transitioning from that dry to that wet season. So if you see an above normal forecast for June, that doesn't mean much. And then when you see an above normal for August, it means a lot more.
Oh, thanks, Becky.
This is Elizabeth. Sorry to interrupt, Emily. I just wanted to say that was Nancy Sellover, for everyone who didn't realize that Nancy was Nancy Sellover, the state climatologist from Arizona. And Nancy will be presenting at the July webinar. So we hope you all can join us then.
And there is one more question that came in. Thank you. And this can be for Brian or all of the other climate experts on the panel as well. And that is, can you estimate how much heavier the monsoon might be in some type of percentage or inches? So really trying to reiterate some of those things that you presented initially.
Well, that's a great question. It's interesting to look back over the past handful of years, for the monsoon here in, for instance, northern Arizona, where 5 out of 7 have been above normal. Is this a trend? Is this something which we're likely to see continue? Given these estimates and given what I've seen over the past, let's say 5 to 7 years, if I had to stick my neck out, I might say somewhere along at least in my neck of the woods, maybe 5 to 10% above normal might be the area I would hedge toward. But as we know, the convective season, the monsoon season is wrought with a tremendous amount of variability. And it's almost more important to focus on how the rainfall falls instead of just how much. You get 3 inches in one cloud burst, and that can really tilt the season in one direction for that specific area versus weeks that might have that same amount.
This is Nancy again. Just to give you an example from a specific location, for Phoenix, the long-term average from 48 to 2016 is 2.6 inches for the whole monsoon. The wettest we ever had was 1984, where we had 9.38 inches, which is like almost 4 times. And the least amount we ever had, it was in 1924, when we only had 0.35 inches. So it's hugely variable in the Southwest.
Yeah, I think that's a really important point about our precipitation variability. Was there anyone else who wanted to respond to that from our panelists?
Emphasizing, this is Becky, emphasizing the variability, not just in a year-to-year basis, but in a location basis. So you may be in a location where you miss out on a lot and you're wondering, why the heck did they say we're going to have an active monsoon and I hardly got any in my spot, and somebody 100 miles away from you could have gotten every single deluge and thought this is a great monsoon. So something to keep in mind.
Excellent, thank you. I don't see any more questions. We will give it another minute. Thank you, all of the participants, for providing such great questions for our panelists. Our organizing team would like to thank Becky Bollinger, the Colorado Assistant State Climatologist, and Brian Klimowski, the meteorologist in charge at the Weather Service in Flagstaff, Arizona. Again, this presentation has been recorded and it will be posted on the drought.gov website. Thank you for attending our collaborative webinar on drought in the Southwest. Please join us again for our next webinar on July 25th with Nancy Sellover, the Arizona State Climatologist, and Ed Delgado of the National Interagency Fire Center Predictive Services. And this concludes the June 2018 Southwest drought webinar. Thank you for attending.